Okay, good afternoon, everyone. Thanks for joining us for the second Mayor's Megawatt Challenge webinar of 2022, Strategic Energy Data Management in Buildings. As always, the content for our webinars is driven by our members. So after meeting with all of our members earlier this year, this was chosen as one of the priority areas of interest for the coming year. For those of you who don't know me, my name is Catherine Wilson. I am the manager of the Mayor's Megawatt Challenge, a program that's been working with municipalities since 2003 to reduce energy use and greenhouse gas emissions in their own facilities. And we're currently supporting our municipalities in their efforts to achieve net zero across their facilities. Before diving in, we'd like to thank our webinar sponsors for today, QMC Metering Solutions and Yorkland Controls, for not only being sponsors of this webinar, but for providing their insights into what municipalities should be considering when developing and implementing their energy data management plans. So the next slide shows today's agenda. So after the welcome and introductions.
Oh, sorry, let me just hold it.
Yep. So after the welcome and introductions, we'll dive right into things you should be considering in your energy data management plan. We'll start by looking at interval data and the importance of obtaining interval metering for all utilities and what this can tell you about the performance of your buildings. We'll discuss the benefits of getting that connected to the BAS, in addition to archiving and having a separate access to it for analytics. We'll then look at sub-metering, and we'll discuss practical guidelines to use for each utility to really determine what should be sub-metered and what the capabilities of the sub-metering should have. We'll then explore what can be done with BAS for more granular monitoring and analysis. We'll then discuss how to build capacity to use the data, monitor it, and take action. And we'll wrap things up with a question and answer period with the audience. So the next slide just has a few instructions here. So please use the chat box for technology-related questions and questions that are unrelated to content. For content-related questions, please use the Q&A option. So these can be logged for the Q&A document that will be circulating after the webinar. So please feel free to ask questions throughout the webinar. Straightforward questions may be answered as we go along the way. Larger questions will be addressed in the Q&A session at the end of the webinar. Any questions that we can't get to will be answered and circulated in that Q&A document that I mentioned. Okay, next slide. So this webinar will be conversation style, again, with an excellent group of panelists here representing both municipalities and vendors. As with all of our webinars, we really strive to bring in the municipal perspective, as folks always want to hear about the experiences, challenges, lessons learned from their municipal counterparts. So I will now ask the panelists to introduce themselves. So Amanda, can we start with you?
Yeah, hi, I'm Amanda Martin, the Corporate Energy Manager at the City of Markham in the Sustainability and Asset Management Department. So I oversee anything pretty much related to energy, which can include energy efficiency, conservation, renewable energy, different policies and programs.
Perfect. Thanks, Amanda. Junaid and JK, would you like to go next?
Good afternoon. My name is Junaid Iqbal. I'm working as a project coordinator, energy management, with the City of Brampton since 2010, and I'm involved in various energy management related initiatives.
Okay. Good afternoon, everyone. As you can see from the screen, my first name is Junaid as well. Just a quick background that you have a better chance of winning a lottery than having this kind of name in the same teams. It's a very rare name. But anyways, as Catherine mentioned, to avoid confusion between me and the original Junaid, people call me JK. I'm the supervisor of energy management at City of Brampton, joined in December. And just like City of Markham, like Amanda mentioned, we're looking after a portfolio of our buildings to see how we can improve energy efficiency, reduce greenhouse gas emissions, and other factors such as our EV charging stations portfolio and solar PV and other renewable energy measures. So looking forward to this discussion today. Thank you.
Thank you so much. Mike.
Good afternoon, everyone. My name is Mike Easton with QMC Metering Solutions. I'm our Chief Revenue Officer at QMC, and I've actually been with the company for about 15 years. I moved to Toronto in 2012 from Vancouver to expand our business into Ontario. And I work with my colleague Peter, who's on this call, on the institutional markets, as well as commercial and multi-residential, where we supply natural gas, electrical, water, and thermal metering solutions, along with software and other services.
Fantastic. Thanks, Mike. Walter.
Good afternoon, everyone. My name is Walt Fuhr. I'm the National Business Development Manager for Yorkland Controls. That includes automation, smart buildings, and critical environments.
Fantastic. Thanks very much. And Frank, last but not least, our very important moderator.
Yeah, so my name is Frank Camilleri. So good afternoon, everyone. I lead the technical team at Interlife, and we provide technical support to the Mayor's Megawatt Challenge program. And specifically on this webinar, I will be moderating, facilitating it. So,
Fantastic. Okay, so I think we're ready to dive right in.
okay, great. So, sort of a little bit of an overview and just to drive some purpose behind this and how important and where does energy data management sort of fit and everything. It's really critical that I know that on many of people's minds these days is getting to zero carbon, and energy data management is extremely critical in this 4-phase process. Many of you may have seen this in previous webinars, but the first step in all of these pathways to getting to net zero is really operational excellence, and that is the first step. The other steps sort of follow afterwards about heat recovery, renewables, on-site renewables, and renewable credits. Those follow as they seem to be determined with an optimized building. They optimize sizing of things and so forth. But what's really critical and how this relates again to today's webinar is that you kind of start off with the monthly utility data, then there's interval meter data at the mains, then there's some meter data, and then we get along with BS trends. Again, just sort of setting the tone for this and why this is important. Before we sort of get into things. And we'll get into obviously the details of each of these topics in more detail to follow. Okay, great. So starting off with the building level. So again, we'll start from the more general in nature. So interval data is extremely important in this quest for optimizing buildings and really knowing what your buildings are doing and sustaining good energy efficient operation. As many of you are probably aware, there's interval meters come pretty well for all different utility types right now. Electrical has been around for the longest and is the one probably most common and easier to procure and install typically. Natural gas interval meters, they are a little bit more difficult and more challenging. Very few are offered from the utilities. And in some cases, because of that, you may need to take matters into your own hands. And this is probably a good time to just ask QMC, Mike, in particular, questions about the natural gas piece here, because before we go into the water and other aspects of it. So for natural gas meters, Mike, do many utility providers have pulses available on the main gas meter to obtain this interval data, and if not readily available, what options are you observing, and what are the approximate costs associated with those solutions?
Yeah, thanks, Frank. Across Canada, we'd estimate that probably about 50% of utilities, maybe 60%, offer a pulse output from their main gas meter. This is on larger buildings like institutional or industrial properties. Even if the meter itself does have an upgrade available, you still need the utility to have the policies and the expertise available to do that upgrade for you. We have had a lot of success doing this across Canada with Enbridge in Ontario, ATCO in Alberta, Fortis in BC, all offer not only the upgrade modules, but also the people and procedures to do the upgrades. And we find this upgrade usually ends up being somewhere between $3,000 and $5,000 to do, because you need the modules, some labor to get that work done. If you're in a jurisdiction where the utility does not allow their natural gas meter to be upgraded, you typically would go with a redundant meter, probably an insertion meter on a larger load. These are fairly accurate. They are fairly easy to install. They're not a revenue grade installation, but nonetheless, they're a good mixture between, or a good balance between cost and accuracy. And so we've been doing a lot of our redundant building level gas meters as insertion meters lately.
You know, thanks, Mike. And that's good that you're seeing there's options available there if you need to take matters into your own hands if the utility just isn't quite there yet, right? So thanks for that. Just to continue on here, in your opinion, what should municipalities know about installing natural gas meters?
Sorry, what should, so
sorry, yeah,
you
what
are
should-
gonna be,
yeah, sorry,
if
Mike,
you're
same
gonna be
question for you.
installing a main natural gas meter or natural gas sub meters, what you want to do first is understand what your application is. If it is, in some instances and for some municipalities, we're actually doing billing applications where they're metering tenants in their space. And if that's the case, it needs to be a Measurement Canada approved meter because Measurement Canada regulates natural gas in Canada. So if that's the case, you're limited to an inline diaphragm or rotary meter that needs to be sealed and commissioned in the field. If it's an energy management natural gas meter, then you have a lot more options open to you. This could include insertion meters, clamp-on meters, or redundant inline meters as well. And so when you're sizing out these natural gas meters, you'll want to know the pressure of the load, the BTU load, and the pipe size so that a vendor can accurately quote you equipment and you get an accurate price on the installation as well.
Great, thanks, Mike. So just moving on to water, again, water monitoring is becoming more popular. I know that in many facilities, especially administrative type facilities, once you get a building to be extremely efficient and optimized, we're noticing, at least in the Ontario market, that water costs can be just as much as natural gas costs, actually. So it's becoming more and more important and more popular, and solutions can be more cost effective these days. Mike, I guess an additional question on there about water meters, sort of similar questions to above, pulses at the mains. What's your, maybe you can elaborate a little bit about the availability of pulses and just water meters in general in your facilities. Mm-hmm.
Yeah, thanks, Frank. Yeah, the necessity to integrate with building level water meters from the municipality is increasing as we're seeing water becoming a much more costly and precious resource. So we're probably only seeing about 15 to 20% of municipalities across the country are making it easy to integrate with their main water meter, whether that's a technical issue or a procedural issue. And when we are, and the City of Toronto is a good example, where we are able to integrate with the meter, what we're able to do is purchase and install new modules that go on the existing meter and provide a pulse output. The city does need to be involved to reseal the meter after that installation is done. And obviously there's some labor necessary to connect that to an energy management platform. One caution we have on this though, is there's a few different meter manufacturers providing building level water metering across the country. And some of those meter manufacturers, when you get those pulse outputs, they're very difficult to integrate, even though it says pulse output. In some cases, you're getting really high readings up to 1,000 pulses a second in some cases. And when you're receiving those, that might not be possible for an energy management system or a data logger to actually collect that accurately. So you need to verify that before the installation is done.
Okay, great. No, thanks for that background. Appreciate it. And again, we understand and we'll continue talking a little bit more about the importance of interval data and the ability to use that information to assess building performance. And I guess we've touched upon it a little bit regarding connectivity to BAS and archiving. We'll get into more of that in details. But we've heard from Mike, the industry.
Frank, can I just add one more thing? Sorry,
yeah,
I didn't give an alternate to that one. If you're not able to get a pulse output from the main feed into the building, it's probably best to either install an inline redundant meter, or we have other technologies, including insertion and clamp on, that are still very accurate, and it saves on doing a full building shutdown to install that meter.
Oh, okay, great. And was that a typical cost I think you might have had for something like that? Was that in the $3,000 to $6,000 range, or is that?
Yeah, somewhere between $3,000 to $6,000 should either be for an insertion or a redundant inline meter. Again, you'd go insertion on larger loads, and you can do an inline redundant meter on smaller loads. Okay,
perfect. Okay, great. Thanks for that. So just continuing on, we've got the perspective of the industry, and I'd like to ask the question from Amanda at the City of Markham, a little bit more about interval meters. So Amanda, how common are interval meters in your buildings? On all these three fronts: electrical, natural gas, and water.
Yeah, it's something we've been working on over the past several years, and we found out in speaking with Electra that if the up until this year, if the buildings had a demand of over 200 kilowatts and a certain consumption threshold, then we were eligible for free meter upgrades. So we tried to take advantage of that as much as possible. As of this year, even more facilities are eligible. I think they said it's like a service of over 50 kilowatts and maybe 250,000 kilowatt hours per year. So it's something we've been working on over the past several years, and we've managed to roll out 24 electricity meters through Electra, our local distribution company. And there's one more in progress. We also have one natural gas meter through Enbridge that we can view through NTRAC when we have access to it. And I'm not aware of any water meters supplied by our utility companies, at least none that we have remote access to. We've also installed one meter at the whole building level separately, like at our own expense, and that's connected to our building automation system.
Okay, good, great. Thanks, Amanda. Yes, and I know the little snark about the natural gas, and as you can see, it's a bit of a challenge to get that, and you can get that working on an ongoing basis. Just to continue on this, just wondering how are you using the information that's being provided by these sub-meters that you have or plan to have in place? Mm-hmm.
Yeah, they've been extremely useful in troubleshooting and researching different ways to save energy, because it's pretty near real-time data. So when we were running the Battle of the Buildings competitions amongst our community centers, I use that regularly. It's much faster than waiting for bills to arrive 2 or 3 months later. We've also used it to identify loads that aren't shutting off overnight. During the pandemic, when we were trying to partially or fully close facilities, we were tracking loads and performance using those meters as well. On large projects, usually if the savings is over $10,000, we would put in a meter. So we could use it for measurement and verification purposes. So we would track ideally we get it in before the project takes place by at least a year. We can track the baseline pre and post after the retrofit is completed.
Okay, that's great. I know that there's many different types of utilities that you can sub-meter, and frankly, I guess the one that's most popular in your places is in your facilities, which is probably the same in most municipalities, is the electricity. Well, I mean, given that you do have a bit of both, I guess, the one natural gas and the several electrical, which ones do you find most useful, at least to date, anyways? Mm-hmm.
Typically the natural gas meter, because we were using it for the Battle of the Buildings competitions. Okay. And with only one gas meter, we kind of had to rely on the bills to compare them all accurately. Plus electricity is one of the more expensive utility. It is the most expensive utility. So from a cost savings standpoint, we were using that one most frequently. But because we're getting more interested in reducing greenhouse gas emissions, I'm sure there will be a lot more appeal to rolling out natural gas meters until we manage to switch away from it. Which
great, yeah, no, that's great. That was actually what I was going to allude to it, and it's great to hear that Mike's offered some suggested alternatives if the local utility is not ready and able to do that. So thanks for that. Appreciate it. So we'll move on to a little bit more about understanding the importance of this interval data. So we mentioned that earlier on, and I think many of you probably have a good feel for the importance of it, but I want to highlight some key items just to show some examples of this. So these might be some typical questions that you would ask at the building level. Kind of look at this energy, kind of like an onion, if you will. You sort of start peeling it slowly and surely to get to the root causes and trying to make things more efficient. So this is kind of the first layer, if you will. But the first layer really is the monthly bills. The second layer is kind of if you're fortunate to have interval data at the main building level. So things like when do peaks occur, and how does weather factor into this? So the graph below is a good example of how you can use that interval data to look at things like that. So for instance, you'll see there that this is a typical week in the summer of an administrative type facility. And you'll see that the peak occurs at the highest outside air temperature. So just a little bit on the graph there. The blue line is the demand usage, the interval data, if you will, and then the dotted line, which the grid is on the right-hand side, is outside air temperature. So you can see that the dotted line there, the grid itself, right over here, they kind of occur at the same time. This is the peak in the electrical demand. This is the peak outside air temperature. So it kind of makes sense that the peak in the building from an electrical perspective, because this is electrically cooled through centrifugal chillers, that it would occur simultaneously with the outside air temperature. So again, this is one question that that you typically answer with interval data. A little bit more challenging to do that with monthly data, right? So other questions are things like baseload energy use. Is it kind of within expectation? So over here, you'll see that there's baseload. This is kind of a weekend, typical weekend. And you can see it's hovering just over 200. Well, as during the week, you'll see that the overnight loads tend to be a little bit higher, and so this is a bit concerning, and you would want to investigate that further. For interval metering will tell you that, right? If you only had monthly data, it wouldn't give you the resolution that you need to do that. And kinds of questions would be, well, why aren't we as good as the weekends, for instance, right? Especially because there isn't any overnight use in the building, right? Tenants are all gone, right? So again, that's another question, and then another question. Again, there's several questions, but another one I just thought I'd show here is the overall profile match, sort of the operating hours, as you can see over here, pretty well every single day, happening over here and over here and over here, and pretty well all through the 5 days. And there's a bit of some occupancy on the weekend, just for a short period of time, but you can see that the demand follows. Fans are shutting down. The chiller plant shuts down, right? So again, this is what you can do with this data, and this is not always the case. So you'll find that sometimes this doesn't drop off. And in fact, I would even question, why is this happening? Why is this gradual? And that's typically because there's cleaners in the place, and things are getting cleaned, and slowly lighting is coming down. So, but again, a lot of information. These are just only a handful of questions. What you can do with interval data at the building level. So another graph I wanted to show is that sometimes with interval data, it's important to ask and say, is there an opportunity to reduce or change the shape of the profile? And in fact, we sometimes find it very useful to compare these profiles to the energy use normalized, obviously, with other similar buildings. So here you'll see we have there's two facilities here. They're both actually community centers, mainly ice rinks in nature. And Terry Miller, which is the city of Brampton facility there, it's actually a multi-use, a multi-purpose community center. And it's fairly similar to this ice rink here that we compared it to. And just a couple of things to note, again, with this interval data is that Terry Miller's doing pretty great from the peaks. It's lower than the yellow. So again, the green graph here is Terry Miller's performance. Again, all normalized watts per square foot to take into consideration, sizes of things, the absolute sizes of things. But you can see though at the bottom though, they're not as good as the comparative ice rink, if you will, with overnight loads. And this would make you question, okay, is there something we can do about that? Are fans running longer, are lights staying on us unnecessarily, right? So again, many things you can do with even interval data at the building level. And again, these are just some examples of that. Okay, great. Okay, so just getting into the moving on to the next layer in of this onion, if you will, is the whole concept of submetering. Again, now this is submetering within the facility itself at different loads, and as you can see over here, just a little bit of an overview of submetering in general. You can see this sort of top layer. This is the data and how to deal with the data. There's cloud-based solutions that QMC is an expert in, and the connectivity to building automation systems is important. And then we're going to talk about when should it be considered? What are good guidelines, and what loads should you be monitoring? Over here, it's showing a chiller, for instance, and as Mike mentioned already, sometimes you have a need because there's a tenant in the facility that you have to submeter it. So there's that. Then there's sometimes you have these really odd loads, and it could be like a data center, it could be something else too, and those are the kinds of things. But we'll get into more of the details of what are good guidelines into creating a submetering plan, if you will, and what is it that you would want to submeter, what makes sort of business sense out there. And you'll just So anyways, and you can see at the building level at the bottom over here, you'll see that, within each of the three different utilities that we talked about, and district energy could be added to that as well, is that there's, in addition to that, you can have sub-meters, obviously relevant for each of the different utility types, right? And we'll go into that a little bit more next. So I think we talked about this a little bit, but at the main building level, we kind of added this little component of thermal, which really can exist as well too as part of the building level. So on district energy systems, thermal can also be something that you look into. But at the sub-metering level, basically, very, very common to see electrical sub-metering. Gas, we've talked about that. It's again, you can sub-meter components there. And when does it make sense? Again, we'll talk more about that later. Thermal, thermal can be really important in cases, especially when there's specific loads that are unique, that are to that facility that you would want to separate. And again, we talked about water, and there may be some opportunities for water sub-metering. And what are good guidelines? Cooling towers, for instance, are typically things that are sub-metered for a whole bunch of reasons, but there may be irrigation system, things like that. And we'll get into that a little bit more, but I just kind of wanted to sort of lay out the four main types of sub-metering categories, if you will. And now what I'd like to do is get into a little bit more of, what is a good sub-metering plan strategy? And what is it that we want to meter? And we hear a lot, especially because electrical has been a little bit more logical to follow and do, because it's something that you can, there's so many different circuits, but there's been this tendency to go overkill on the electrical meter load. So after discussions and experience with QMC and so forth, and other metering is that really the focus should be on big equipment, key loads. You're better off trying to save money on and putting in sub-metering for other utilities as well. As we mentioned, gas is becoming more important, thermal and water as well. On that note, we're going to talk a little bit more about some of the motivations for doing this from the perspective of clients and energy managers within the municipalities. And again, just some general guidelines, and we'll get into more of those guidelines in the next slide or two. Again, thermal loads, large air handling units, sometimes when it makes sense, if they're big systems there. Chiller plants, we think is a really good idea, in water as well. What I'd like to do is ask City of Brampton and JK in particular. We saw that other slide there, previous slide there, with respect to Terry Miller. So Terry Miller, for a little bit of background, again, is a multi-purpose community center, but it has an ice rink in there, and they did put in a sub-meter on the whole ice rink refrigeration plant with the support of QMC involved in that piece of it. And so JK, I want to ask you a question regarding that. What was the motivation for you to install that sub-meter for the refrigeration plant at the Terry Miller site?
Thank you, Frank. So again, it comes back to the overall motivation and goals that we have at City of Brampton in terms of from an energy management perspective. To give a little bit of context, in 2019, the City of Brampton released the Energy and Emissions Management Plan from 2019 to 2024, Zero Carbon Transitions, which aims to achieve a zero carbon transition for the city's new and existing corporate facilities. This plan outlines three key objectives, namely to minimize emissions intensity, to maximize cost recovery. And what City of Brampton plans to do with this is City of Brampton aims to substantially reduce and ultimately eliminate greenhouse gas emissions by achieving 20% energy reduction over the 2010 baseline by 2024, which is fast approaching, and greenhouse gas emission targets of the ones which are set by the governments, namely the main one, which is the 100% reduction by 2050. So coming back to the point that recreational facilities account for nearly 50% of City of Brampton's annual greenhouse gas emissions. This is the data that we collected as per our 2019 broader public sector BPS reporting. And ice rinks are the largest consumer of electricity within recreation facilities. To give a little bit of background, Terry Miller's ice rink contributes to about 22% of the building's total electricity consumption. And again, we cannot manage what we don't measure, as this was mentioned earlier. To optimize and conserve energy plus to reduce our carbon footprint, we need to measure electricity consumptions and rinks to develop strategic solutions to achieve our targets.
So thank you, JK. Appreciate that. And yes, the ice rinks definitely are a big, large consumer. And in this facility over here, as you mentioned, it's 22%, and it's important to sort of separate that from the rest of it. So great, all great motivations for putting in the sub-metering. Just a question for you, and how the city has been able to use this data so far.
Sure. So the city has used this data to support a net zero ice rink feasibility study that was completed at Terry Miller Recreation Center. And the sub-meter information is also used by our recreation operations team for planning of their operating budget, because electricity accounts for a huge amount of our OPEX operational expenditures per year. So it's important for our recreation operations team to account that into our budgeting. And also, data is used to sensitize the operations team on the electricity consumption of the rinks. Many a times, the operations team might not have an idea of how much electricity is being used by these systems. So it's good to give them an idea of the load that is being consumed by, in this particular case, the ice rink. And this data can also be used for developing baseline and for using measurement and verification of energy conservation measures implemented. Let's just say like we use this data, and one measure that comes to mind is perhaps like energy recovery or a heat recovery unit. So this is where this data can also be used. And one thing that also comes to mind is to assist us in predictive maintenance of cities' assets. Right now, as all of us know, in the industry as a whole, we are moving away from preventive sort of maintenance, scheduled time-based maintenance, to predictive maintenance. And this data can also help us in terms of developing some predictive maintenance plans for the major assets. Like you mentioned, it does not make sense to install sub-meters on everything, but it does make sense to identify some of the major assets and install these sub-meters. So it could also help us in advancing our predictive maintenance strategy.
Mm-hmm. No, thanks. That's very helpful, and we'll see later on in the presentation specifics about that site and the specific items that are being sub-metered. So for sure, that's very helpful. So a question for the other Junaid. Is the city contemplating? As I know you've been there for 10 years and you have a bit more history to you. Just from your perspective, is the city contemplating doing this in other buildings? And what's your current thinking on that at this point in time? Mm-hmm.
Yeah, thanks, Frank. So the answer is yes. The city is intending to utilize sub-metering across its facility with the aim to provide tenant sub-meter information as part of the cost recovery, its cost recovery. So that means we are involved in a project which will involve around 11 facility where we are installing a sub-meter system for the tenants, and the aim will offers like a cost recovery, and also greenhouse gas emission reduction and energy conservation strategy is a major core goal is. And also, I don't want to forget this, because with the sub-metering information, we always have the ability to measure and verify energy saving for implemented energy conservation measures.
Yeah, thanks for that. That last one's a really important one. I mean, they all are important, but yeah, one of the great things about the sub-metering aspect, especially in a big facility like like a Terry Miller and in other buildings where there's big loads, is that you can really isolate it. And it's very easy to prove how effective a measure is. And also not only how effective it is, but how it can continue to be sustained in that way, right? Because it's very easy. We'll show later in the webinar that how things can go awry if you don't monitor it. So, so just a question for the City of Markham. So thanks, Sinead. A question for Amanda. A similar question. Have you installed any sub-metering in? I mean, we talked about it in your facilities. What kind of loads have you really typically sub-metered in your facilities?
We have sub-meters more recently on the Simcoe refrigeration plants. There's 7 meters installed with the upgrade of their system. We
Great.
also have meters on our solar PV assets, 4 in total. There's several meters on the CHP, and actually your slide previously reminded me that we use the interval meter to analyze the base load and determining the size for the CHP because we wanted to run 24/7, maximizing base load.
Yes.
We also have 4 buildings with advanced sub-metering systems. So dozens of meters tying back to, unfortunately, different centralized platforms in each of the facilities.
Mhm.
We're looking to migrate all of those to one centralized platform instead of managing multiple logins. And then we've, as I alluded to earlier, we've also added sub-metering systems on larger energy saving retrofit projects so we could complete M&V. Typically, if the load isn't dispersed across the building, but we're targeting a specific asset, then we can add a meter to it. If it's whole, like a recommissioning where it kind of touched everything all across the building, then we would use the interval meters.
Okay, no, that's great, Amanda. Thanks for that. Again, very similar to City of Brampton's comments about being very useful tool to be able to prove ECMs and then sustain those measures as well. So so great. So thanks everyone for the comments on that. The next slide I want to talk about, there's so many considerations you need to think about. We'll try to distill it into a handful of items. So here are a handful of items that are just listed on this slide, but I'm going to resort to talking to the panel, asking the panel a little bit more about this. But IT is a big item. Cybersecurity very related to that. The reliability of the data is important. Access to storage and kind of interoperability is kind of interrelated to accessing it and connecting it to the BAS. Implementation costs are obviously things that you would want to consider. We talked about when does it make sense to be sub-metering something, and being mindful of the costs that are continuing on, if you will, be it for watching and using the data if there's some costs associated with that, but definitely from a maintenance perspective, as Mike touched upon a little bit about that. But without further ado, Mike, again, some key things that hopefully you can clarify for us. So what are the key considerations regarding installation, interaction with other equipment and operations of sub-meters, and maybe some of the challenges as it relates to this touchy subject of remote access? We heard Amanda talk a little bit about it, and security, IT, and that in that kind of realm, if you will.
Yeah, thanks, Frank. I'll try and touch on IT and data collection issues first.
Yep.
If you remember the slide a few ago, it showed data going to both a web-based solution and an on-site solution like the building automation system. So you can do one or the other, you can do both. And really it's up to the project or the property management and operations team to decide what they want. If you're going to be doing an on-site integration, the most important thing is that you standardize the protocols that are going to be used. Because if the meter supplier is providing one protocol and the building automation company is looking for another, it's going to be a really expensive fix to replace the meter with something the BAS can utilize. So in institutional properties and commercial properties, we're really seeing Modbus and BACnet being the 2 most utilized open protocol solutions. There's some other ones that are just still in some meter manufacturers like Hart and Profibus Communications. Those are just not being utilized very much anymore. So I try and stay clear of those and really factor in Modbus or BACnet, which again seem to be very utilized these days. If you are going to be doing a web-based solution or getting the data out of the building, I believe the historic way that companies have wanted, or the properties have wanted to do it is utilizing the base building network. But we've really been finding this as a struggle lately with whether it's an institutional portfolio or a commercial portfolio. Integrating with the base building network to hang metering on that is actually quite a challenge. So what we've really been moving our customers to is a cellular solution where the meters are completely independent of the base building network, but they have a direct cellular communication. And this used to be frowned upon because there was a lot of cost with installing cellular equipment, monthly fees, but cellular fees are so low now and meter data is so minimal that the cost of doing these integrations is very low. It's also very secure and very private. These are utilized in military or financial institutions. So, you know, the checks and balances have been done there to utilize cellular communications. And again, you can do both. You can have your data being remotely collected by cellular. You can have a direct Modbus integration into your BAS. You can do both if necessary. Once the data is collected online, you can really do whatever you want with it. You can utilize one platform to do all your reading and reporting, or you can API that data to a variety of different solutions. So if you have a benchmarking solution or an advanced analytics or fault detection solution, you can pass the data over there via API. And so really the data is yours and you can transfer it to whoever you need to. I'd say one other consideration that needs to be factored in is just ensuring that all stakeholders are communicating what parameters or measurements they want out of the meters. So if you're installing a meter that's only going to give kilowatt hour consumption or natural gas consumption, but one of the other stakeholders wants instantaneous data, they want pressures, they want kilowatt demand, they want power factor or harmonics, that needs to be communicated early on. And often that isn't. And again, it can result in a costly swap out of the hardware if the specifications are not being met or not meeting what the end operator wants. So those are our cautions. One other note that we're coming across lately is there is a lot of temporary metering available in the market. And that's really a balance that the property needs to make. If it's a very short-term project, you could use a temporary solution like a clamp-on meter. But there's a good analogy here that low-hanging fruit comes back or grows back, and we like to see for almost the same cost a permanent solution be installed in most properties.
Okay, that's very helpful. Yes, I would concur with you that the slightly additional cost of something that's temporary to go permanent. It's been our experience that things just go awry right afterwards. So that definitely, I think the economics could be shown fairly easily to justify that permanent installation.
It might be a 25 or 30% adder to go with a permanent solution as opposed to a one that's there for a month. Okay. So I would recommend a permanent.
Okay, no, that's great. That's very helpful, and glad to see you've managed to find some solutions that are more acceptable today with respect to the IT issues there. Some of the operational considerations. What are some of the things that you need to be mindful of? Recalibration and things of that nature, replacement. Maybe you can elaborate a little bit more on that.
Yeah, sure. You'd mentioned earlier that electrical meters were kind of the mainstay of building level or sub-meter solutions, and that is very accurate. And so because of that, electrical meters tend to have a very long field life. They typically don't need recalibration for around 10 years, but if you want to be on the ball, you could do it every 5 years. But with more mechanical metering being done, you do need there's quite a variance in the amount of the re-verification periods, recalibration periods necessary. So if we mentioned Measurement Canada earlier, if you've got a Measurement Canada approved meter in, say, for gas, or a utility grade meter in for water, you're probably good leaving that meter in the field for 8 to 10 years before even needing to check its accuracy, because there's so many of those deployed at a utility scale. The accuracy of those meters is very good for the long term. On the other end of the spectrum, you can get into an insertion water meter that's got an impeller or like a little propeller on it. If it's installed in a system that's got debris in it, it's not maintained well, or hard water, you might need to check on that meter every year, because the damage to the impeller can be such that your readings are way down. And then even insertion ultrasonic meters that don't have moving parts, they probably should get a review every 2 to 3 years, again, depending on site conditions, just to at least remove them and clean the apparatus so that it's functioning properly.
Okay, no, that's great. That's fantastic. And yes, my personal experience has been with the insertion type, where again they tend to be more accurate for sure initially. And that's the question. If they're not maintained, you're not going to get that repeatability of accuracy. So that's a great point to bring on. You've talked about many. Many different items over here. Which of these items that you've talked about seems to be more readily resolvable today rather than a few years back?
Yeah, well, we just discussed insertion meters. You commented on their accuracy. So insertion meters and clamp-on meters, the technology is definitely improving as metering becomes more necessary for all property types. The different manufacturers are putting more R&D into it and coming out with better technologies. And also the companies installing them, whether it's contractors or meter specialists, are getting more experience with the equipment as well. So the equipment itself is being deployed better, more accurate with, say, less straight run necessary, and the installation of them and the commissioning of them is also being done better than it historically has been. So the industry, I'd say the clamp-on and insertion industry in general is getting better. So that's allowing more flexibility in the meter installs. We talked a bit about communication challenges as well. And if you're not getting data out of your meters, they're really irrelevant to your building automation system or your energy management system. So ensuring that there's constant communications with the meter is really critical, and that can fail for a variety of reasons. You can have somebody sever a hardwired connection into a meter. You can have other connectivity issues. Somebody changes some networking issues, programming. And so one of the things that more advanced energy management systems do is they keep continuous track of these meters and automate a response to somebody at the property or a vendor to let them know that there is down communications, and therefore they can take proactive steps to improve that meter communications or fix it, instead of when you go to look at the data 3 months later and you have zeros or just blanks. That's too late. So we really I think one of the better technologies is this instantaneous feedback from the systems to let you know if a meter's down.
Okay, that's great. No, that's very helpful. Yes. A question for Amanda. Again, we talked about IT and security, and we know that this can be a bit of a challenging area. What was your experience at your municipality for installing these sub-meters and in dealing with, again, IT and security?
Generally, my experience with IT has been pretty good.
Great.
Yeah. Historically, when we installed sub-meters, IT was very ready to work with us. They would just ask questions like, is the data going to be stored on their server versus an external server? Because it can affect how they set up the ports and other components. And they would provide us with IP addresses and help us run data drops to the meters. But with security and higher focus in the last couple of years, I've heard that they now do a really thorough security assessment, and it's difficult to get smart web-enabled devices connected. I haven't personally tried to install new meters in the last year or two, so I can't speak to the experience directly. Mm-hmm. But our BAS coordinator has, and he's tried to get remote access for vendors since we're installing new systems, so they're commissioning and they need access frequently, even with the ongoing service and maintenance agreements. And it's been a challenge. I know one of our sub-metering systems also got shut down due to a cybersecurity bug. So we're working on getting that reconnected through a different, potentially tying back to our BAS rather than the system that it was operating on.
Okay.
It's a moving target.
Yeah, no, absolutely. No. And I mean, like I said, I've heard these stories about it getting a little bit better, but then all it takes is one cybersecurity attack and you're done. Like, I mean, and then the IT's back is up, and rightfully so. I mean, so again, it's a bit of a struggle ongoing with this. But given your experience today, what advice would you give someone who is kind of contemplating installing sub-metering, and if they were to go do it now? Mm-hmm.
I have a few pieces of advice that maybe you've already thought of, but maybe this will be a new idea. So first would be developing an implementation plan with a solid business case, which are the target facilities that you want to start rolling out, and then gradually work away from there. And it depends on what your priorities are. In our case, it was energy competitions, or if we have major retrofits planned and we want to do measurement verification on it, then that would set those facilities a little higher in the priority scale. Also, personally, maybe the metering companies don't want to hear this, but I always try to prioritize as many free meters as possible through the utility companies.
Yep.
They install them, own, operate, and maintain. So it's easier from our end. We just have to run a cable for them, and then we access the data through their software. And then what we're building up to is creating a standardized scope, standardized designs, brands. It depends what type of data you need, but we're looking at standardizing how long we store the data and what frequencies, 15 minutes versus hourly, tying back to one central platform. We did try several different types of meters and found they all had pros and cons. It was good to test and it was insightful, but now to manage the number of login credentials we need to maintain, we're looking to move to one centralized platform. And the last bit of advice I would say is engage IT as early as possible. Like when you know you need a meter is a good starting point, because sometimes they need quite a bit of lead time. Now there could be extra security assessments. They could have staffing shortages. So it's good to engage them early and help pinpoint like where the locations are going to be, how many meters we're going to need, so we can run the cables and make sure we have the data available before, or at least when we need it.
No, that's great. Those are very helpful guidelines. And again, we understand that there's still issues and that you're facing, but it sounds like you're making some headway, be it by standardizing scope and engaging IT early. So that's great. Just a quick question for yourself, Junaid, I guess. Same question for you. What's been your challenges? Briefly, maybe describe a bit of your interaction with IT and security issues that you've had to deal with regarding this.
Yeah. Thanks, Frank. I think Amanda explained very well with respect to the security and IT concerns and issue and their role during the projects. So that's pretty good explained. So my understanding, and my experience is the support from IT department is very necessary and valuable during the implementation of the project in terms of assessing risk and providing guidance with respect to the placement of data drops, equipment, and city IT network usage. So because city needed accurate real-time and online sub-meter information, as such, IT department was engaged to support online access to the sub-meter data while meeting city IT security requirements. And also, IT and security evaluated the product and made sure that new product will not bring any risk with it. They also helped us to decide the proper placement of these units on the network based on the risk presented.
If I can add quickly to what Junaid mentioned and great points mentioned by Amanda, from my previous experience in the pharma sector, whereby we were installing sub-meters, one of the mistakes that were typically made from an engineering project management perspective is key stakeholders like IT were involved in implementation phase, and by that time it was already too late. So from a change control perspective and assessment perspective, IT is a key stakeholder and should be involved right from the beginning, from the time the project charter is developed and from the time the design begins. This way, IT knows the project and IT can give as much support as possible. And this can avoid any confrontation or difficult times when IT is involved from an implementation phase.
Okay, thanks for that.
Just to add one more thing, actually, as Amanda mentioned, now after COVID-19 situation, now security protocols are more strict nowadays. So it used to be easy, fairly easy, but now you have to go all the security protocols, and which will lead us to spend more time for the project. But I think as the time goes, they are bringing more and more kind of SOPs and all the guidelines. So we'll be more and we'll have more information regarding these projects.
Okay. Thank you, both JK and Junaid and Amanda for those. I mean, common theme here is get IT involved very early on, right from inception, so you avoid issues down the line. And it sounds like the last couple of years, especially with all the pandemic and remote access to things, security's gotten an issue. So even more reason to get them involved. So again, thanks very much for your comments. Everyone. I'd like to move into a little bit more about some of the how to use this data, if you will, a little bit, and some dashboards that are available. There are quite a few. There's quite a bit of capabilities in some of the sub-metering software that's available out there. You can get a main dashboard, and these main dashboards, can be they need to be customized to your liking and kind of information that you think you need to best manage it. And so having some even general big data, just very simple data available, is very, very useful. Again, lots of flexibility to meet your specific needs. Again, these are just some examples over here of it. Again, many of you, as you're managing a portfolio of buildings, there's some software out there that can look at a multitude of buildings as well. And also there's a lot of software out there that can help you compare energy use indices of similar buildings. Again, a lot of different capabilities out there. Try to take advantage of those while you can. So because there is a lot of flexibility there and to do what makes sense for your specific situation. But again, there's a lot of capabilities out there. So there's a lot you can do. Just take your time to understand the capabilities and what makes sense for yourself. Again, this is kind of a portfolio view. And then this is another sample where it's a building snapshot. So again, that was a portfolio view, but this is a good snapshot of what a building is doing. The good thing about this one here, you can get things like Energy Star scores presented right in the snapshot. CO2, again, talking about the main impetus for this webinar, or we feel is one of the main impetuses is emission reduction. So you can get that breakdown over here. You can see that, and you can see the overall EUI, and over here as well, what you can see is you can see that within each of the utilities. So it's great to see all the different utilities, but also to see what makes up some sub-meter data that's available in this electrical piece here. Some of these panels here, right? So again, lots of variety and lots of flexibility in what you can do and what's available out there from a metering. The sub-metering software out there. Just continuing on, you can get into some really detailed analytics with some of the advanced graphing features. So here's just an example. And we'll get into a couple of examples that I've dealt with, and talk about exactly how you use this. But again, we talk about how you use this data to really look at look at individual things and setting alerts. I mean, there's software, again, there's software out there that takes advantage of this to highlight and set alerts for high, low consumption. Again, there's so much data out there. It's how do you take that information and how do you efficiently use it? And so again, setting alerts is a good one to do. And even if you start off with sort of broad alerts, if you will, initially, so you can manage that. That's good. And the good things that they're getting more and more sophisticated. These capabilities that, as you know, much of the energy that's used in a facility is really related to other parameters like outside air. So having that being plotted on the same, in the same sort of dashboard, if you will, is really, really good, right? So again, just trying to highlight the fact that there are there's a lot of capability out there, and it's becoming more and more sophisticated as time progresses, right? So that can really help you at the end of the day manage your facility and keep it efficient. So here's an example. I talked a little bit about Terry Miller, and we said we would run into it and talk a little bit about more. This is actually data from the Terry Miller sub-metering that was installed there. So just what can this tell us? A little bit more detail here. You can see that the orange line here is the whole, they're sub-metering the whole panel, but not only they're just doing the panel, they're actually sub-metering the equipment itself. And what's really good about this is that it gives you orders of magnitude of the different types of equipment. So again, this is the overall aggregate, but you can see here, this is one compressor, and this is the other compressor. So both this light blue and this yellow kind of yellowish color, if you will, you'll see that, the compressors in the grand scheme of things make up the single, the most energy using equipment of the refrigeration plant. Probably not a surprise to you, but it's good to know that and validate that and verify that. One of the things that you notice, again, there's many things you could do. We could probably spend a half an hour on this, but I just wanted to show you that, both compressors seem to be running together all the time. Right. And is that the most efficient way of operating it? And I would challenge that. And I think those are the kinds of things that you would get into and try to analyze a little bit further as well. Then you got other parameters in here, like brine pump is sort of another item that ends up using a lot of energy. Then you get into the evaporator condensers. But this is very helpful information. Again, not just that you're submetering the refrigeration plant on its own, but what makes up that energy. And then we'll get into a little bit more detail about how do you go even deeper than this to understand and make this process even more efficient. And that's when you start using your building automation system to trend things that are not necessarily energy related. But again, one of the things that's really good about submetering this is you really capture the interactive effects of it. So one little tidbit of information that I'll share, some of you may or may not know this, is that as again, we talked about the compressors being the biggest load here. So there's a strategy out there to be said that your condensers, running your condensers a little bit harder, you might get a little bit of an increase in that energy, if you will, but because it's so small, it is more than offset by the savings you get in running your compressors more efficiently. So again, if you try to optimize each piece of equipment on its own in isolation, you won't optimize the plant. But being able to play around with that and having this whole refrigeration plant submetered, you can test those different theories, and you can see what actually works out to be the best in optimizing this, right? So anyways, that's that piece there. Again, a lot can be told, and this is just an example of what can be done with one of them. Just again, another view of this, this sort of bluey color, if you will, grayish blue color here. That color there is really the whole panel, but it gives you, again, and this is another way of looking at the amount, the magnitudes of each type of equipment. So again, the compressors, these two here, seem to be using the most energy. Again, just reiterating then the kind of the brine pump sort of comes in next, right? Again, just different views of the same type of information just to help you manage it, right? So here we go. So not trying to make the business case. We've heard many, Amanda and Mike, and as well as City of Brampton, Janine and JK talking about, how do you justify this? And they've made the comments of, creating a business case, having a plan for it. And again, we want to be mindful that you can't do everything. But here's just a couple of case studies that would just warrant and it could help you justify the installation of submetering data. In this case over here, this ended up being a fairly larger air handling unit. And this is just an example, again, of what submetering could do. I mean, this could be done with submetering, a combination of that or even a BAS, but you can see over here where there's no schedule in use, and this is not uncommon. Probably many of you do it. Everyone has good intentions. There's a schedule in place. Someone, for whatever reason, there's a problem with a location, or there's a problem after hours, they put it in manual override. I see this over and over again. And if you're not monitoring it, if you're not setting alerts, if you're not doing any of that, it can go unnoticed, undetected for a very long time, right? But then if you can put some alerts in place to quickly catch it and restore it back into the automatic mode, getting those manual overrides out and back into auto mode, it's great. So I mean, this is just one example of a fairly fair size air handling unit that give you like $3,600 in cost savings. That you've avoided because you had this in place, if you will. So when you put things in perspective, the simple payback, if you will, don't like to use that word a lot, but the economics can be fairly attractive for these meters when it's big equipment that's at stake here. Another example here was with water. This is, again, becoming more and more important, as I mentioned, as water is becoming a scarce resource and the costs of it are becoming more and more greater and greater with the passage of time. This is just one example where there was a faulty flush valve, if you will, and you can see that just, again, it was not really initially detected. Again, you wouldn't have detected if you didn't have something like this necessarily. It lost 100 cubic meters of water over a 75-day period. Now, again, that may not seem like too much. That may be $400 or $500, but what was it was first of all, it was found because of the sub-metering system, sort of I alerted that, but there were 5 previous leaks in this specific situation here where they found something similar to that. And in aggregate, those 5 leaks, saved saved about $11,000 if they'd gone undetected. And I'll just add one more to it. I was involved with a hospital firsthand that had a leak of $10,000 leak every month for 4 months. And even with us watching it, it took 4 months to find it. And that's why there's a need to even think about where do we submeter things. But, that was a $40,000 or $50,000 expenditure. And, not having watched the interval data, a lot of them, especially in the accounting department, were thinking that, oh, they had heard that water costs had gone up like considerably. They alluded that that was the case. But as you can see, if you're submetering and you're watching it, you're using that data, you'll know right away that that is not just an increase in cost, it's an increase in water. And it's quite substantial. I mean, they were ecstatic when they found where the leak was, and so but that all comes down by monitoring and the submeter and interval data, right? So again, just another example of making the business case here for this. So just getting down again, another layer within the onion that I talk about. So you got the main interval data, you've got then you've got some metering, and then you've got BAS that again drills in a little bit further. So some things to be considered, with your BAS is obviously the sub-meter data. Mike alluded to it, talked about it, and some of the other panelists have mentioned it as well. But integrating this sub-metering data into the BAS, I guess there's a lot of solutions out there available today that can integrate with it, because especially this could be extremely important with demand shedding and so forth. So there's the technologies out there, the protocols are there that you can integrate the data, be it separately on a cloud as well as into the BAS. So something to keep in mind. The use of BAS trend logs are critical to optimize things that are not energy related. So the example would be even the Terry Miller refrigeration plant as an example. So it's great that they're submetering that, but the reality is that the way that plant is controlled, it's controlled to maintain things like temperatures. And so, you would need to know, okay, well, why is the compressor acting in the way it is? Why is the condenser fans running in the way that they are, right? And so that involves more than just energy, capturing that energy. So that's why this is where the BAS and the use of the trend logs of other parameters that motivate and are the catalyst for the way the equipment operates is essential to it. That gives you that layer deep. And I'll show a real quick case study on how you can use that, how it all started from some meter data and how it was resolved using trends. Again, we've heard a little bit of this before. Some points can be used in lieu of submetering. Again, that judgment call that you make for it, and we'd like to talk a little bit about using CTs, for instance, a little bit on there, and I know that the CTs, current transducers, instead of statuses. I have a bit of a history with building automation system. There used to be these status points would just recognize that power was going to a motor, and you would think it's actually operating, and in some cases kind of is, and sometimes it may not be. So that's becoming a commonplace, as well as now many fans and pumps and so forth have BFDs, and you could take advantage of that, which kind of brings me to Walter. Some questions for you. This is how you can use your building automation system strategically these days to help you with this monitoring as well, and trying to find that right balance of what submetering is, and trying to be able to do a couple of things with your building automation system, as opposed to achieve both power understanding of power requirements and understanding of building operations. So just from your perspective, Walter, are you seeing a trend to using CTs versus like a status relay, if you will, on motors, air handling units, pumps, compressors, and things of that nature?
Yes, Frank, we are. And you were correct. They were more originally used for like a status on off. And now more and more we're seeing that you can actually measure current with them. For example, is the fan running? Isn't it running? And also you need a virtual meter to see the power consumed. Now, when you use a CT in this way, it's not an exact calculation, but over time, you can establish benchmarks and reference points quite simply by doing this. So if it's not a critical application where you need something, but you want to know what power is being used, it's a very cost-effective way to do it.
Okay, no, that's great. And the cost difference these days of CTs versus status points, especially when VFDs are not available. VFDs typically have that available, but we're still not all there on all the equipment. What's your take on that? What's the difference in cost from your perspective that you're seeing out there?
Really, the cost now has become insignificant because they seem to be used in the majority of design parameters. So I would say there really is no cost difference to the end user.
Okay, no, that's great to hear for sure. And yes, and and to your point about the accuracy of these things. Again, I understand that sometimes the accuracy of the CTs are a little bit, but they can be used in a very useful way. So an example might be is that all of us it's establishing patterns and benchmarking. So all of a sudden, motors being using so many amps for such a long time, then all of a sudden it drops, and that could be an indication that the motor's either failed or the belts have come off the fan, right? So there's many ways of using this data, and it's so much more useful than just the status point that was there before. And good to hear that the cost of them is indifferent. So why would you do anything but put CTs on there, right? So
correct. It's just a little bit more work for the BAS, but you're right. You go with one that can measure, definitely.
Yeah. Okay. Great. No, that's very helpful. So thanks very much for that. So I'll again, I promised an example of how to use optimization and how the processes can work using BAS trends. So I just want to talk a little bit about a heating plant optimization a bit more. So this kind of was instigated. There was a heating. Many folks over here have talked about on the panel, both from the industry as well as the municipalities about measures. So a measure was being done or was done in a facility a few years back, and then recent trends from the interval gas data at the building level indicated, wow, there's this big jump in gas usage, and it was occurring over a 3-month period, and just couldn't figure out what's going on. And so I wanted to stress how this could be useful. And so again, some trends in the BAS here just will show this over here is that one of the biggest things one of the measures was trying to achieve initially was really unoccupied setback, and there was a bit of a change in the facility. There was some concern about boiler return water temperature, maybe creating a problem for the boilers that are non-condensing. They get damaged if the boiler return water temperature. So once you got that indication, if you will, that alert, because they're monitoring with the specific client, they're monitoring the data, especially even on a weekly basis through interval data. They noticed again gas usage. So all of that, you dig deeper and you see what's trying to find it. So here, one of the checks is that you can see over here is that we talked about there being an unoccupied setback. In this specific building, they have standalone controls on the perimeter controls, so they don't have controls on convectors and things of that nature. So this is kind of what the measure was just really reducing the heating loop temperature to the building during unoccupied periods. And as you can see over here, the set point is close to 90 degrees, but you can see the actual temperature, this green line over here, was not setting back. Right, so you're seeing that this stayed up to 130. Well, if all the individual, convectors or their valves are opening up because you're trying to cool off the building, 130 degrees still gives off quite a bit of heat, right? So we were trying to figure why isn't that happening, and that could be a big contributor to loss of savings, for instance. So again, this is one view of it, and we wanted to make sure there was a big concern from an equipment maintenance perspective that the boiler return water temperature didn't go below 140. You get condensation. These boilers here are not condensing. So again, this is just one view about how you dig deeper. That first starts off with interval data. You're not waiting for the monthly bills to come in. Interval data to show you that there's some issues with gas increase all of a sudden. So here's again some continued investigation through the trends. And you'll see over here, a couple things we wanted to check over here is that, first of all, efficiency goes down because these boilers are fairly large. We want to make sure that only one boiler operates at a time. So you can see here, this red this red graph here is there's a little bit of oscillation, but it's not bad. It's within acceptable range, and it's only red operating here, and then over here it's only the blue operating, which means that at this point in time only boiler 2 is running and boiler 1 is not. and vice versa over here. Only boiler 1 is operating, boiler 2. So we verified that, said, okay, great. This other piece is a key parameter is called the heating mixing valve position. And one of the main reasons for doing this is that they were getting a lot of fluctuation in the gas consumption, probably maybe about 8 months or a year ago, that caused them to, they say, well, we got to do something about that. That's creating quite a bit of short cycling. So they decided to put a minimum position on the valve to create a bit of volume in the big boiler loop, right? I mean, with the valve at 0%. So this valve over here, if this was here at 0%, they were seeing that like this graph here during unoccupied periods was cycling like crazy, right? So there's one of the solutions was to, okay, let's just put a minimum position. Well, they just arbitrarily chose 30%. Okay, and so again, you know, the measure was working reasonably well, and then someone took some action to try to deal with an issue, and this is what happened. And again, this is just another view. This is more digital points, digital on off. So again, just further supporting that only one boiler and burners on at one time. So during this time here, there's only boiler 2 is running, and then this is only boiler 1 again, just to make sure that the boilers are off. And then there was only a small period of time. Sometimes the boiler plant will shut off if it's mild outside, and this was the case over here. But during this other days over here, it wasn't so much. There were cold days and they needed to run. But I think what I want to highlight is that now this is the consolidated view. You know, being able to see all of these 3 graphs that I showed previously separately, being able to see them all together over here. That is really a great way of using your trends, and this is what this consolidated view really helped with resolving the issue. And the conclusion was basically is that this minimum position of 30% was just open too much. And once they saw that, as you can see the gap between here that I showed previously, once they reduced this to say 10%, for instance, then the actual return water loop temperature got down to very close to the set point of 90 degrees, and then their gas usage got back in track. And this kind of leads to a lot of questions that follow. Is that we've talked about putting all this information at the main meter, having good interval data, having some metering data, and having tread logs. But one thing to keep in mind here is that I've seen it happen a lot where they're put in place and they're not used. Good to hear that the panelists, City of Brampton and Markham are starting to use them a bit more, but try not to fall into that trap. We've seen it time and time again that you put all this metering in place and all this data, but no one's really looking at it. So what we would like to highlight is that it's really critical to establish a process to use this data, monitor, and really take action when things happen, and that can be very overwhelming. And it's totally understandable. Existing staff, we've seen it, especially a few years ago, when you're seeing a lot of these trends and alerts coming in. They don't have the bandwidth. People are dealing with their regular jobs. This is an add-on typically to their workloads. Recommissioning projects also take advantage of the data, but once the projects are over, a lot of things do go awry. Many have said that it's in here, and it's been my personal firsthand experience and that was a perfect example of it, where measure was set up properly, working reasonably well, and then it went awry. So, but there's a need to monitor it in order to sustain the energy efficient operation. And what I'd like to do is highlight the fact, and I know that there was a webinar in March that talked about fault detection and diagnostics, but it has a role here as well. I know that many of the municipalities may not be at the sophisticated stage yet, but something to be very mindful. Again, just keeping this in front and center when they're looking about getting all this data. And that, in fact, those graphs that I showed you, and especially the consolidated view, is a view that you can get from an FDD. Here at Enerlife, we use internally a fault detection and diagnostics tool. So this can help identify issues and anomalies in a more automated manner. Faults, there's tons of faults that can be can occur, and it can be extremely overwhelming when you initially set them up, depending on how sophisticated you do. But you really do need someone to interpret them, investigate them, and rectify things. And again, if not done properly, it can be very overwhelming, and things can get abandoned, right? So again, regular monitoring is key, along with prioritization of these faults, right? So again, when you get to a sophisticated level where you're at a point where you're monitoring a lot of this data, using a lot of this data, you really need to think about a process that could be put in place. And there are organizations that provide this service at relatively affordable costs. But I want to talk to you a little bit more to Walter, and put this question to you, Walter. What trends are you seeing in the uptake for fault detection and diagnostics?
Probably one of the biggest trends is not that many years ago, it was an education discovery for customers and users at all ends to see what it was about. And now it's, especially in the last couple of years, it's come to the point where organizations are actually driving this for human comfort and other levels of human interaction. And one of the things that in the fault detection that has been coming forward is what's known as people counting. Whereas opposed to say you have you're monitoring CO2 and volatile particulate, et cetera, in a room, and you have a meeting, and now the ppm has hit that 1,000, 1,200 level, and now the VFD HVAC goes into a mode, full mode. Well, all of a sudden the meeting's empty and there's no one in the room anymore. So, it kind of defeats that purpose. By using something like people counting, for example, the VFDs and the HVAC will count it up to maybe the VFDs comes on at 40%, 60%, and the occupants don't really even notice. They don't notice that they're comfortable. And so you can use that to also the energy savings, as opposed to ramping up equipment 100% when you may not need to.
Mm-hmm. No, that's great. It's great to see the uptake is getting better and better with FDD. I know I've known about it for probably about 8 years or so, and I've been heavily involved with it firsthand in quite depth for 4 years. From your experience, for those that are successful with FDD, what really makes them successful? What makes having that system successful?
Well, they usually have a champion that will bring it forward. But also, one good way to do it, and we see it a lot, is you start off with smaller projects or smaller areas in your building, and you see how they work for you. And as you move on and go to larger areas or to a different building, you can see how you can improve things internally, because it's really the customer who drives this and how they want it done, how they want changes done. You may have a building that really doesn't have BAS, but you want to improve the indoor air quality, or you can go to larger projects as well. Some can be as simple as they're just doing it on a spreadsheet, or you can have what you showed earlier, like a single pane of glass, where you can monitor the entire building at once.
Mm-hmm. No, that's great. And again, with that's out there, like I said, some organizations want to do this internally. In terms of, and I've seen firsthand, there are firms popping up that are monitoring to help out their third parties, if you will. What are you seeing in terms of those types of services? Are you seeing more to provide these services? What's your observation in terms of internal versus external, and what you're seeing in the marketplace?
That covers a really broad spectrum, because we have customers who have the internal capabilities all the way through to run them themselves. They can also bring in a third party to assist, or it can all be subbed out. A combination of both we find works really well, because your building's the best, mm-hmm. and that way you can guide people through the process, and changes can be done even before implementation. So it's a better way of just all around communication. And yes, this has been emphasized a lot. IT comes on just as the process even begins, because there's parameters that every building follows differently. So getting those out of the way right away is the best way to do it.
Great. No, thanks. Appreciate that. Yes, definitely concur that people that know the building should be part of the team, if you will. So thanks again, Walter. Appreciate that. So just again, from just wanted to highlight some experience of a process that does work. We've been working with the client a few clients that have a place in place since 2018. Initially, it was crazy, but just a real brief outline of this as we're nearing the end of time here. They have regular meetings. In this specific case, there's monthly meetings. This team consists of a monitoring party, the facility operations staff are definitely involved in this. The BAS service provider sometimes brought in, and the sustainability energy efficiency management. They, again, without being overwhelmed, they review top 5 items and they prioritize it based on what they think is important. In this specific case, it was occupant comfort and energy efficiency. Action items are documented and a ticket is open, and basically with that, the team leaves. The right parties get together, they investigate the anomalies, and that could be not addressed in the meeting, and they come back, and basically that ticket sort of remains open until it's resolved. So anyways, a process does, processes like this do work. I've seen it in action, seen it and been part of them for several years now. So just wanted to give you some encouragement that these things can work successfully if they're done properly, right? So here, Catherine, done a lot of talking. Over to you.
Thanks, Frank. I just wanted to make sure to leave a minute or two at the end for Q&A here. So I'll just go through this really quickly, but just wanted everyone to be aware, if you're not already, that there are funding opportunities available specifically for the implementation of this data management software through the Federation of Canadian Municipalities. They're offering the CBR, the Monitoring and Analysis Grant. So it's a grant for 80% of eligible project costs up to $25,000, and procurement and installation of sub-metering system is included in this. So I just wanted to make sure everyone was aware of that. And you will see this circulated to you after the webinar. Just want to make sure we have a few moments for Q&A. I don't see any open questions in the box right now, but if anybody has any questions, please feel free to ask them now. And if not, or while we're waiting for some questions, maybe get our final thoughts from some of our panelists. Mike, are you still? Yep, there you are.
I'm still here. Wanted to
Final thoughts, comments?
Yeah, just I wanted to just comment on something that was said a few times, just on utilizing the main utility meters. We agree, even though we're a sub-metering company, the best meters you can get are the ones that are already in a building, whether that's the main utility meters or existing sub-meters that you already have invested in that just aren't working, whether they're not communicating, they haven't been commissioned. Do an audit, see what's there, and utilize that first before you order any other meters. Please, because it's a waste of infrastructure you already have if it's not being used. And most meters that have been installed in the last 10 years can be upgraded to be utilized by an EMS or a BAS with minor modifications.
Excellent.
Excellent.
Thank you. Walt, any final thoughts? Comments?
Just that, people, individuals, companies, looking to make better use of their buildings all the way around in all aspects. I just think it's great for not just the environment, but it's a good business case, and it works really well. And there's a lot of technology out there. It can be a bit overwhelming. So if you have questions, just ask someone, see what they have to say. If it works for you, move forward. If not, look at something else.
Fantastic. Thanks very much. Okay, I don't see any other open questions, but there were a few questions along the way that have been answered. So we'll make sure that those are circulated in the question and answer document that we send out after the webinar. So you'll see all of that. And we'll also send along a little bit of the commentary that happened today between the panelists and moderator. So that wraps things up for this webinar. I'd like to thank everyone again for joining us. I'd like to thank again our sponsors, QMC Metering Solutions and Yorkland Controls, for all of your input and advice today. That was fantastic. Thank you, Frank, for moderating. Thanks so much to Junaid and the other Junaid, JK from Brampton, and Amanda from Markham for sharing your municipal perspective. It's always really appreciated by our other municipalities to hear from you folks. So really, really appreciated. And thanks to all of our attendees as well. If you think of any questions in the next few days, that you would like to ask, please feel free to reach out to me at my email here, and we'll be happy to include those in the document at the end. So thank you very much, everyone. Take care and see you later.
Okay,
Thanks.
thanks, everyone.
Thanks, everyone. Thank you.
Thank you.
Thank you.
Thanks, everyone. Bye.
Bye.